Hello everyone and welcome back to Arctic Retro. In this episode I'm gonna take a further look at this Spectravideo 728. That was a complete trash, I would say, but I started a repair process. I made one video already. Hope you've seen that. In this video I'm gonna continue on that journey. So it's the end of June now, and this is the last video before my summer vacation, which starts next week. And I'll be gone for 4 weeks, so no more videos until August, I guess. Today has been a very nice and warm day, 22 degrees Celsius, and I've been out in the sun the whole afternoon. I feel it in my skin, but it was a nice day. Just to give you a quick recap about this machine, I got it from my friend Robert over in Sweden as a donation. He didn't know anything about it, but I opened it and checked out what was wrong with it. As you can see, there's a few keys missing. I think I'm gonna be able to fix that. However, the worst part was the actual inside of the machine. While I tested that the motherboard in fact worked and I got a video signal out of it, the power supply and the video module over here is completely broken. So I figured this machine has had a fall or something, because yeah, there's some breaks straight over almost the whole board where all the traces were broken. And yeah, there's actually multiple breaks. The big capacitor here was almost broken off. Some of these large diodes had breaks there around the pins. So I tried to fix it by gluing it and then fixing the broken traces with solder, but I could never get it to work. You can check out that video if you want to see more. So I actually thought that there was no hope for this machine, that I'm just gonna have it as a parts machine. But then I was just thinking, why not to replace the whole thing here with something more modern? And that is what I'm gonna try today. And then we need to replace the power supply here with something else, and also the video circuitry here has to be removed and replaced with something else. This video is sponsored by PCBWay. In my videos I often have the need for some PCBs for my projects, and my favorite PCB manufacturer is of course PCBWay. If you need to have produced your own PCBs, then just head over to PCBWay, where you can upload your Gerber files directly, or you can choose from a wide variety of ready-made PCB designs. PCBWay can also support you in your other hobbyist needs, like 3D printing, CNC machining, sheet metal fabrication, injection molding, and other services. Right now they are running a campaign where you can enter a competition and where you can win a lot of nice prizes and coupons. For example, if you order for $59 or more, you get a $10 discount. PCBWay also has a lot of other products that they sell, and right now they have a lot of cool gadgets at a discount. Yes, I won the ESP-W Room 32 Wi-Fi. So check out PCBWay right now and see what kind of discounts you can get for your next project. At first I thought about just using a component converter. I have a component to HDMI converter that I tested, because the video signals from the video chip, they are okay. But I couldn't get that to work, so I'm gonna check a little bit more about that. But I want to have the composite video output working as my first goal. I know there's some modern solutions here where you can buy some module that you place under the video chip here, and it provides RGB signals out. So I might look into that, but I'm not really sure what type of video chip is in this machine. It has this heatsink on it, so I can't tell for sure, and I'm not really sure if there are any solutions for this particular video chip, because it's a little bit different to the chips that were used in most other Spectravideos. It looks like a mess here with cables. That's because I was actually just soldering in some wires here to the video output of the motherboard. That actually goes over here and gets converted into composite and RF output, yeah, I just soldered those in to try to connect them to a component input, but as I said, that didn't work. However, one of the pins here provides you with I think it's the Luma signal that actually you can connect directly to a composite video input and you get a picture, but only black and white, and that is what I did, and that in fact worked. So I then knew that this motherboard is in fact working. But first of all, I'm gonna remove this board here, and then I'm gonna see what I'm gonna do with regards to the video. But first I'm gonna replace the power supply. This machine takes in some AC voltages from an external power supply, and it's a very unusual power contact, and it's a very unusual power supply, so it's hard to find. I don't have the power supply that came with this machine. So I think it's like 18 volts AC and 7.5 volts AC, and that gets converted here on this board into 12 and 5 volts DC. So that's more regular, more usual voltages, and that's kind of easy to find a modern replacement for. Obviously you don't find anything that fits directly into the case here, so I'll probably have to do some modifications. I will have to replace the power input here with something else, maybe do something with the power switch, but I think it will work. So first of all, I'm gonna just remove the whole board here, take a closer look at it. It has a couple of screws, and it has these big transistors here that uses this large heatsink, so all that can be removed. Yeah, so this whole thing is now loose. We can take a look at it. Yeah, let's take a look at the damage. It's on the back side, and you can see here there's a break all the way here, and it goes further. I tried to yeah, it goes all the way over here. I tried to just solder and bridge the different parts here, but in the end it didn't work anyway, because probably something else is broken. I made this bodge wire here. Yeah, here was a big damage. Loose pins, they were broken out of the PCB for these diodes, at least one of them. So the AC power here, the low voltage AC comes in here. There's a power switch, and this gets converted to plus 12 and minus 12, I think, and plus 5 volts. There's the ground, and from this it goes over to the motherboard as the correct voltages. And that was just soldered in with these yellow wires. I just removed them before. So that's one part of this board. The other part is the video circuitry, and the main part there is this TBA520 chip that does some video conversion, and then it goes over here to composite video here. The audio comes directly from the motherboard. It's not going into this circuitry here. Yeah, and there's this RF modulator that then converts it into RF. So it's not that complicated. Obviously I have the schematics. This is the schematics for the power regulation. I'm not gonna go deep into that, but it's there for reference. So it's not a very complicated circuit. It uses some transistors and the voltage regulator, And obviously it has the bridge rectifier, which is those large diodes that we saw. The video circuit is not too complicated either. It takes the input from the video chip in the machine directly. Some pins goes directly to the TBA 520. Some goes via some transistors, and there's some supporting circuitry, and then it gets out here as this is composite video out, PAL, monitor video. I'm not sure if that's something else. And there's the RF video, that is the RF modulator box. So yeah, pretty easy to understand, but I'm not sure if this is the route to go to replicate this. Obviously I could desolder the different parts and then just recreate this circuit on some perf board or something like that. But I'm not sure if this chip works. And yeah, there's some components, some are probably not necessary, but I think it will be a lot of work to try to desolder this and replicate it with a big chance of failure. I was never able to test if the video circuitry here was actually working because the power supply didn't work, so I wasn't able to power up this board at all, because obviously it uses the same power that the power supply here generates. It might be possible to power it externally, I mean the video circuit, just to check if it's working. Before I continue, I'm gonna unscrew the keyboard here because yeah, it's just in the way. At least if I remove the top cover, it's a little bit easier to handle. So that's easier. Now this front cover has a break here, but it's almost not visible, and yeah, if you push it you see it. I'm gonna put some glue there, but otherwise the case is in good shape. One of these standoffs were broken before I have glued it back on. So Robert told me that he remembered that he got this on the e-waste facility. So it has probably been delivered in as non-working, and then it might have been thrown in some container or something. That's why it has these damages. For a long time now I have tried to find the replacement keycaps for this machine, but I didn't find any. No, I didn't find any for sale or anything. But on Thingiverse there's a 3D model. This is the keycap. Gonna print some of those, and this is the key plunger. So that's quite lucky. This was made in 2020. So what am I gonna use to replace the power supply from this PCB? Well, I got this one. It's a little Meanwell power supply, and it has 3 output voltages. It has 5 volts, plus 12 volt and minus 12 volts. So this is perfect. And as you can see, it's quite small. It takes in 230 volts AC. And I was thinking about replacing the power contact with this, just a regular IEC contact. It's that what it's called. So I just need to solder in a wire from and a contact from there to this, and try to fit this into the machine. Then on this side we have the outputs, and these will go directly to the motherboard. And this will go into the machine like so. There's some screw holes. At least I can secure one of these holes into there. I think the other ones, I'm not sure. I might just use some glue. This is hobbyist work. It's not professional. And just to warn you, if you don't know what you're doing, working with high voltage, mains voltage like this, you should not try this at home because it's dangerous. You know, if you connect up live to this connector and you accidentally touch it or touch some of the components on this side, then you will get shocked. So this is the high voltage side of the power supply, and we can see here it's a clear separation here. And this is the low voltage side. The reason for this separation is obviously that there should be no possibility for current to travel between the high voltage and the low voltage. And also there's this separation with these cutouts, and that's to prevent arcing from this side over to this side. But I'm definitely not a power supply expert. However, I know what dangers lie behind these, so I'll be careful. This connector, if we're lucky, it just fits. It doesn't, it's a little bit too big. So I guess that's just to cut out a little piece of the case here. Obviously I could just take a wire from the power supply and out here, and you could connect it directly to mains, but that's gonna look ugly, and that will make strain on the power supply. With this large hole, it's not easy to secure the cable going out, so I'm definitely using this. So I'm actually going to start with adapting this hole so this contact fits. I mean, it's a little bit wide with these fastenings, so I'm not really sure how that's going to turn out, but yeah, let's see. Yeah, it's 19.3, so we need to cut out 4 millimeters. So that's what I'm gonna make. We have the contact here. It's going into a smaller hole here. I can't draw. Well, I think I'm clever today. I actually was about to start cutting out a larger hole here, but then why not put it on the inside, and then the contact actually fits through that hole. So yeah, much better, and it goes, yeah, very nicely into there. I'm simply gonna drill holes through here. It's gonna be awfully close to the power switch here, but I think I can make that work. There's a little bit of leeway this way here, so I can place it all the way to the right. Now I just pushed it all the way in, and it stays there nicely, so now I can actually mark the holes very easily. So here's where I have to drill. This one is not ideal. It's very close to the power button, and I think, yeah, of course the fastening, it will cover it. So, not really sure if that's gonna work, but obviously I can cut off a little piece of that. I'm gonna remove the whole thing, the motherboard and everything, so I can gain easier access to drilling. Yeah, that looks better. So there's some metal inserts in the screw holes. Yeah, and the hole is 2.7 millimeters. So that's gonna fit a screw like this. It's 2.8. Yeah, so I need at least 2.8. Yeah, let's see now if I can drill straight. The drill is a little bit too big, so I don't get it perfectly straight, but I think this is fair enough. Yeah, that looks alright. So now I'm gonna solder in the power wire. It needs to be a little bit thicker, so it's easier to solder it now. I could of course use some spade contacts here. Yeah, I think I'll do that. I was thinking I'm gonna solder it, but yeah, obviously it's made for these contacts. Yes, that makes it easier, no soldering. I'm just thinning the wires. Yes. Just to make sure that accident doesn't happen, I'm gonna use these shrink wrap tubes around. so that we have less exposure to the mains voltage. That secures the connection nicely. There's still a little bit of metal visible there, but this will have to do. Now I need some screws to fasten it with. I think these are okay, maybe these. So I will have to take it off again because I need to cut a little bit of that side there. But does this go in now? Yes, perfect fit. I'm not really sure if I can reuse the same power switch, and I'm not really sure if I want to keep a power switch at all because it's not that necessary, but it's nice to have. Just need to prepare the wire for crimping on some contacts. Just push them down. Yeah, that's good. Also need to make a contact for this side. On this side there's 6 contacts. There's 2 for V1, there's 2 ground, and V2 and V3. Yes, even if the tool is a little bit too small for these contacts, it works. Yeah, I use the blue as the ground or the common, and then brown for all the rest. So these should go in like this then. Well, it seems I have the wrong connector type because you have this edge here, but on this connector you have this edge on the outside, so it's supposed to have a connector that goes outside. But if I cut off that edge, I think it's gonna be okay. But it's kind of loose. But that will have to do for now. Yeah, that's okay. I'm gonna find the correct connectors. How do I find the correct connectors? I guess I have to take a look at the data sheet for this power supply and see what it says and try to find the correct ones from that. Anyway, let's see if we have the correct voltages. I have in fact not tested this power supply at all, so I don't know. By the way, this is not hooked up to live yet. But now I'm turning it on and we should see some voltages. These in the middle are ground. We should have 5 volts there. Yeah, that's exact. Ground, and then 12, 11.66 and minus 12. Minus 10.42 seems a little bit low. I don't know if there's any adjustment screws on this, but if you're dealing with power supplies like this, where you have mains in, you see this big capacitor, it goes up to 240 volts. Now if I touch the leads, I might get shocked, but probably it has some resistors that drains it after it's turned off. But always be careful. No, I don't see any adjustment pots or anything here. I went to AliExpress and I think I found the correct contacts. These are called JST-VHR, and that's what the datasheet for the power supply says. So I think these are the correct ones. I just ordered a couple, but I was thinking I could have fixed this easily by just desoldering the contact. I mean, I have the opposite contact as well. And as a temporary solution, I just glued this contact to the other one, so it should stick now and don't fall out. I want to see what this chip is, so yeah, it was quite loose already. Just a piece of aluminium glued on top. Yes, I just looked up this chip the 9129, and it's a variant of the TMS 9918. But this outputs video on a little bit different format. It's not the component signals, it's the Y, PB and PR signals at 50 Hz. So this is usually used in PAL machines. Push it down upside down. Now, last night I was printing some parts. I actually found the keycap and the key stem plunger, and I printed a couple of those just to see what looks best, if it's printed upside down or this way. Okay, let me see now, will this fit? I mean, I'm a little bit worried about yeah, you know, the keyboard comes here and it goes all the way down. However, all the way back here there's no keyboard, and the top case is obviously taller, so I need to try and place it over here. Yeah, you see my issue here. The contacts here are way too big, they're in the way. I cannot get this over there. So now all the different wires for the voltages finished. Looks alright. Or maybe thinking a little bit outside the box here, maybe I can place it on the side like this. I think that fits very nicely, but I'll just leave it here until I've finished with everything. And the next thing now is actually to test if the machine still works. I was thinking just solder in a couple of wires for the video. We only get black and white video now, but that's enough just to test if the machine works. So now I can just feed these wires onto this RCA contact, see if we get some video out. Let's see now, turning on the machine. There is no signal. Okay, I need to check out a few things. I checked with the oscilloscope and there's no video signal coming out now. Wonder what I have done wrong here. Maybe I mixed up the voltages, but I had it working last time I worked on this machine. I got the video signal from it, but the motherboard is running. I checked the RAM chips, they had 5 volts, and yeah, that looks alright. I hope I didn't ruin this board some way, or that it suddenly stopped working. By the way, now that the power supply is under load, the voltages are more correct. Indeed, I spoke too soon. There is a video signal out after all. I think I just had the oscilloscope wrongly configured with the timings, but if you see the Y, that's not right. Okay, so I accidentally set the probe to 10x. That was the clock signal. If we take a look at the video output on the chip, so it looks something like that. That's the Y and that's the BY. So that looks like a video signal to me, and I also get the same on those pins on the board. Looks exactly the same. There is something strange going on. If I probe the Y signal output, it looks normal, around 3 volts. However, if I connect the two, however, if I connect the video cable to my TV, it goes crazy. So maybe I was just unlucky and the VDP chip has died or something. While I was probing the VDP, and I found good signals on all the addressing lines and data bus lines, but then suddenly it's like it shut down and there was nothing. I now have a clean signal on the CPU on all the pins, or at least most of the pins that I have tested. Address bus and data bus looks fine. Okay, so this video then turned into be even more complex, so I might have to split it into several parts unless it's going to be too long. But seems we have to do some fault finding here. No video signal. I'm gonna check a couple of other machines if I have the same VDP chip. But what I was thinking for the next step, if I had a video signal out, I was thinking about replicating the video chip and the video circuitry by taking out the TBA 520 chip and the transistors and stuff that's necessary for composite video out, at least. I'm pretty sure it's gonna be a little bit difficult and the chance of success will be low, but at least I think I'm gonna try that. Well, there's always something that happens, isn't it? I actually did a big, terrible mistake. I told you I'm gonna print a small enclosure for this power supply, and I actually started to design the model, but I haven't printed it yet. But I managed to blow this and short out this power supply. You don't see it now, I cleaned it up, but what happened? I had one of these lying on my bench here, and I didn't notice it, but I had put it on top of it and turned it on, and boom! The fuse in my house blew. Both of the internal fuses in the power supply blew, and I tried to actually just as a test to see if it would work if I just bridged the fuses where the fuses were. Not that I'm gonna use it, but the power supply is blown. But I thought I'll show you something funny or interesting or dangerous. I said that it's dangerous to work with power supplies even if they are powered off. And now it's actually powered on live. And yeah, there's no output voltages, so it's completely dead. Now I turn it off. This big capacitor holds a big charge. And what else do you think I did when I messed around with this? Well, I managed to short these leads, so let's see what happens now. I'm gonna zoom in. Ooh! Oh my god. So, that's why it's dangerous to work with these power supplies. And the sparks went over here, so I probably blew out that little chip. Okay, so I'm gonna use another power supply, and I order a new one of these. Make sure it's in an enclosure, because now I don't have nerves to work with such a power supply anymore. This one is the one I used in the last video about this machine, and it's obviously more safe. However, this one I think is too big to fit in this machine. That's why I got the smaller one. But it has the correct voltages, so I can just use this then. As usual, I don't have the proper contact to connect to, but I just took out the metal contact from this other contact housing, and they fit quite nicely down there. Ta med bilden på detta. Alright, so I found another TMS 9929A chip, and yeah, I have several machines that has this chip. First I opened the Spectravideo 328, and it has this chip, but it was soldered into the motherboard, so I didn't want to start desoldering or anything. That machine works perfectly fine. Then I thought about the TI-994A, which supposedly has this chip, and it actually had, but that was a lot of more unscrewing. And last time I tried that machine, it was working. So yeah, now I can test this. Yeah, let's see now if we get any other result. I already ordered 2 of those chips, so they're coming hopefully in a couple of weeks. Well, let's turn it on now. Hope I don't break this one. Yeah, and there's nothing on this too. No signal over there. Yeah, looking at the scope, it's the same with this chip. It runs. There's activity on the pins, but nothing on the video output. Well, I think I spoke too soon. I adjusted the time base a little bit, and yeah, that looks like some kind of signal, a video signal, but I'm not sure if that's correct or not. Now, I think I'm at the dead end here. I need to search elsewhere. I think both the chips are working. However, something's preventing the video signal from being generated. Oh, I actually noticed something. I was looking closely at the board and yeah, I think I accidentally touched this crystal and it's all loose. But it's not the solder points, it's the pins that the pin here on this side that goes inside the crystal. And yeah, so I actually took the oscilloscope and measured the crystal, and yes, it is in fact damaged. There's no oscillation signal from it, but if I push it hard down, then there is some signal there. Let's see if I can manage to do it again. Yeah, so now I'm probing one of the pins of the oscillator, and as you can see, there's no signal. This is a 10 megahertz oscillator. However, if I push it down with my finger, then you see there's a signal. If I let go, then it disappears. So that oscillator is damaged. I probably just got lucky last time when I tested this machine. Let me try and desolder the oscillator and take a look at it. Yeah, it's out, and definitely the crystal is directly connected to the VDP chip. Pin 39 and 40. This pin is all loose and can be pushed in. I wonder if these can be opened and in fact fixed, or I need to find a 10.738 megahertz crystal then. So I found another crystal, same value, and I soldered it in. Now the signal from the crystal is okay, but still it doesn't work. It doesn't give any video output. Look at that. Yeah, it actually works now. So the next thing I'm going to do now is to install this TMS to RGB. That might be a little bit interesting. Let's see if I can pull off that. Alright then, that was it for this video. I hope you enjoyed it. You have to wait until August for the next part. I just want to say thanks for watching, and I wish you a very nice summer. And a special thanks to my patrons and my members on YouTube. If you didn't subscribe already, I hope you will do that now. Thanks a lot. Bye bye.